Honor students, you want to get your Circles Quick Reference Guide out for this lesson, turning to this Circle Angles page. We're going to be going through this page. Let's recap what we learned previously and you were just tested on. So right here, just as a quick recap, when you have a central angle, the measure of that central angle to the arc the same. So angle equals arc. Then we had inscribed angles. Inscribed and tan chord have the same equation. Same position, same equation. If the vertex is in the same position, you're going to be getting the same equation. Inscribed angle, tan chord. Both cases, the angle is half the arc that it is grabbing. So whatever direction that is, the angle equals half the arc. So both of them right here, the measure of those angles are equal to half the arc. Those are what we've learned so far. Now we're going to talk about a chord-chord. And a chord-chord is made up of two chords not going through the center. Two chords not going through the center. And in a chord-chord, technically you have two angles. And the reason is because they're vertical. So both of these angles, which are going to be the same, so both of these angles, the measure of the angle, equals the average of the arcs. It's strides, straddles. So either of those angles is going to equal to the average of the arcs. Arc plus arc over 2. That's a chord-chord angle. Is half the sum of the arcs it strides. Then we have these three angles. All of these vertexes start outside. Same position, same equation. So a secant, secant. Secant goes through the circle at 2 points. Or you can go through the circle ending. Both of those are secants. Tangent, secant. Tangent at 1 point. Secant at 2. Then you have a tan-tan. In all three of these scenarios, this angle back here, angle equals. It's going to be this big arc on the far side. Big arc. I'm going to use capital letters. Big arc on the far side. Capital letters to represent big arc. Big arc on the far side. Minus little arc. Right here. Big arc minus little arc over 2. Big arc minus little arc over 2. You're going to have to memorize these equations. So I'm going to run through the song. You might want to hum along, and I'm going to be singing from the top. And again, you're going to have to memorize these equations. I can't emphasize that enough. So it's important that you have this memorized. It says, measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc, it's plain. A tan chord angle is the same as the one inscribed. A chord-chord angle's half the sum of the arcs it strides. Secant, secant, tangent, secant, tangent, tan angles are all the difference of their arcs multiplied by half. All the difference means subtract, of the arcs multiplied by half. So the way I remember that, when the vertex is out, you subtract. When the vertex is in, you add. Keep that where you can see it. You're going to need that for today's lesson. Now let's go to the notes. Right here. Additional angle relationships in circles. So this is a tan chord. And it says, if a tangent and a secant or a chord intersects a circle at the point of tangency, the measure of the angle formed is half of the intercepted arc. So in other words, again, this angle is half of the arc that it's facing. That's a tan chord, also known as a tan secant. It has the same equation as inscribed. So right here, let's go ahead and do this problem together. See that 90 degrees? So if this is 142 here, this angle back here is going to be half, which is 71. Notice I'm completely ignoring what I'm trying to find. It's always good just to find everything possible, and then you just tick off what you're trying to find. So notice right now I'm completely ignoring right there. We see we have a 90-degree angle, so I'm going to find this angle. 71 minus 19. 71 minus from 90 is, of course, 19. Once again, this angle is half of that arc, so you can double this arc. Of course, we get 38. Keep asking yourself, what else can you find here? If right here we have 142 and 38, that's 180. So we can come around here and find this side, of course. That's going to be 180. Now it says find B, C, D. You already have that. Measure of that is 71 degrees. Look at the arc ABC. Now that's an arc, so we're going to sweep around. I'm going to do that in green. Start at A, go through B, all the way to C. And of course you see that that is 180 degrees. So that makes that a semicircle. Let's try this one. From what we just learned, the measure of, that's a tan chord. So sweep the angle and then sweep the arc it's grabbing. Angle equals half the arc. So if this is 166, back here you simply go half. You get 83. Notice, once again, I'm totally ignoring what I'm trying to find. I just simply find everything that you can find. Coming down here, if this is 71, and we're still operating on the angle equals half the arc, the angle 71, that means from here to here. Of course, it's double of 71, which makes this 142. Of course, we know that this whole thing adds up to 360, so I'm just going to continue finding everything possible. And we're going to add 142 142 and 166. 308. That means from here to here is 52, which makes this angle back here, which is also inscribed, 26. Now, you go back and you actually look, STU. So we trace STU, we already found that. That equals 83 degrees. And then S2R, we already found that. That's 142. So once again, notice I do not go for what I'm trying to find right off the bat. I simply focus on the diagram, find everything possible. Then, after you've squeezed out all the information possible, then you just kind of hunt away at these angles. It's much easier that way. Don't hunt for individual things. Just ask yourself, what could I possibly find? And find everything possible. I use the terminology, squeeze the sponge. Squeeze out all the information that you can. Alrighty, so a chord-chord. Two chords intersecting. Each of these chords are half the sum of the arcs they stride. Stride, straddle, whatever you want to call it. All right, so we're going to find all possible angles, and we can find these two angles. I write the equation. Angle equals arc plus arc over 2. So I have angle equals 1 arc 100 plus 32 over 2. Of course, that's 132. And we know that the measure of the angle SQR is going to equal 66. I'd like you to try this one on your own, please. Pause the video, do that middle one on your own. Okay, welcome back. Let's see how we did here. Again, on your own. We're looking for RNM. So R, okay, watch that, DC. RNM. So that's what we're actually looking for. There's a good chance nearly half of you got this wrong, because if all you did was 91 plus 225 divided by 2, and that's 158. That is not the answer you want. So you take a close look here, you end up with a linear pair. So to get the angle we wanted, which was this one right here, RNM, that's going to be 180 minus 158, which makes that 22 degrees. So be careful what's being looked for. Okay, try that last one on your own. Pause the video, then restart when you're done. Welcome back. Let's see how you did. Again, be very careful what's being asked for. ABD, ABD, that's this angle right here. So it is just add the arcs and divide by 2, so 65 and 37. 102 divided by 2, of course, we get 51. Okay, the last three, we have ourselves just a label here. Remember, let's label these. This is a secant. This is a tangent, so a tangent secant. This is a tan-tan. And this is a secant secant. Trick to these is every single one of them, the vertex is out. And if the vertex is out, it is arc minus arc over 2. Out, out. Arc minus arc over 2. So in this case, when you use these equations, please go ahead and make sure you always write two sides with an equal sign. Okay, so this is going to be angle equals big arc minus little arc over 2. Now you go ahead and x is going to equal big arc, which is 174, of course, minus little arc, 98 divided by 2. Do your math longhand. Please avoid using calculators, guys, for simple addition and subtraction. I beg you. And of course, so that equals 76, and then you divide by 2. And we get x equals 38. I like you to do this one on your own, please. Pause the video, and then we'll go over it. Pause the video, do your own work. Welcome back. So this is a tan-tan, so it's angle equals big arc minus little arc over 2. So your first complication is the fact that you don't have a big arc. You go like this. You're like, wait a minute. There's no big arc, but I do have a little arc, 132. So you come over here, and what you notice is, of course, you can go all the way around and get 360. So you find the big arc. That's going to be angle equals, that's 360 minus 132. So 360 minus 132. That's 228. So this is 228. Then you do the math. Big arc, 228 minus little arc, 132 over 2. Come here in the margin, do your own work. You should have did 228 minus 132. We get 96, and then of course 96 divided by 2 is 48. This one I want you to do on your own, please. Pause the video and then restart. All right, this is where it's really important to write the equation with two sides and an equal sign. So we got angle equals big arc minus little arc over 2. In this case, you have the angle. So our angle is going to be 25 equals big arc, which is 83, minus the little arc, which is our x, over 2. We're going to pop that over 1, cross multiply. You should have gotten 50 equals 83 minus unknown, minus 83 both sides. And of course I get negative 33 equals negative x, so x equals 33 degrees. So now we're going to give an example of when this comes in handy. It says when a person is farsighted, which means they can see far away but not up close. Light enters the eye and it's focused behind the retina, meaning the focus, instead of hitting the retina, the theoretical focus of the eyeball is actually past the retina. In the eye shown, light converges at R. If the measure of PS is 60, PS is this outer arc, 60 degrees, and QT is 14 degrees, what would this measure of this angle be? Angle equals big arc minus little arc over 2. You do your own math. Pause the video, then restart. Welcome back. You should have gotten 60 minus 14 over 2. That's going to be 46 divided by 2, which equals, of course, 23 degrees. So the angle behind the retina there is 23 degrees. Understanding what that angle is helps the doctor put corrective lenses here. Glasses, actually technically if it's farsighted, the glass lens would look like this. It would be what's called a convex. That's right. We're talking farsighted, not nearsighted. So the glasses would look like this, a convex shape for farsighted. And the reason is by doing that, it's going to converge that focus a little bit closer. It's going to converge that light focus a little bit closer so that it hits the retina. So that's part of the corrective lenses, is understanding what that angle is. It says right here, 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. So we got 2 muscles, and they're called the superior oblique muscle and the inferior oblique muscle. And if, in this case, the measure of the arc AEB going this way is 225, what would be the measure of this angle back here? Let's write our equation. Angle equals big arc minus this little arc over 2. You go ahead and do this one on your own. Pause the video and then restart when you're done. All right, welcome back. Let's see how you did. We don't have the angle, but we do have this big arc, which is 255. Excuse me, that's 225. I take that back. 225. I didn't circle plug chug. 225 minus. So here you had to subtract from 360 to get that one. So it's 360 minus 225. Really committed to do everything as longhand as much as possible. So that's 135 over 2. So now we're going to go ahead and do 225 minus 135. And the measure of that angle is going to be 45 degrees, because it's 90 divided by 2. All right, so to summarize, when the vertex is on the circle, its angle equals half the arc. When the vertex is in the circle, here's on, On, in, its angle equals arc plus arc over 2. When the vertex is out, out, its angle equals arc, big arc minus little arc over 2. These pages are done on your own. Check the work on the board when you're finished.